Hi everyone, this is Mr. Ensler, and welcome to another Review Explained. This is the Chapter 4 Review Explained. And hopefully, if you need some extra review, this will help you. There's also a good way to check your answers. And I try to go really slowly through every problem so that everyone can understand it and learn and prepare for the test and really soak up all the things that we learned. So on this first page, we have the same directions for all these problems. Find the value of x, then classify the triangle by the angle. So we have to say whether it's acute, right, obtuse, or equiangular, as well as by its sides. Is it scalene, isosceles, equilateral? They all have at least two classifications, and some special triangles have more than two. So let's look at this number one. All right, we have 2x, 3x, and 4x. I don't know what x is, but I know there's 180 degrees in a triangle, so I can just set this up as an equation. 2x plus 3x plus 4x equals 180. All the angles inside a triangle add up to 180, always. So 2 plus 3 plus 4 is 9x equals 180 degrees. So then we're just going to divide by 9. So x equals 20. That is part of my answer. It says up in the directions, find the value of x. But then we're just going to plug 20 in for all these. So this top angle, 2 times 20, is 40 degrees. This bottom left, 3 times 20 is 60. And bottom right, 4 times 20 is 80. And you can see that those three angles do add up to 180. All right, so now to classify it. Let's first look at the angles. All of these angles are less than 90 degrees, so that means it is an acute triangle. Now, they don't tell us anything specific about the sides, but in the very last lesson of this chapter, 4.7, what we learned is that if some of the angles are the same, that means some of the sides will be the same. In this case, none of the angles are the same, so that means none of the sides will be the same. So I do know for sure that this is a scalene triangle, that none of the sides are the same. All right, let's look at number 2. So same kind of thing here, except we are given some clues. We know that this is an equilateral triangle right off the bat. All three sides are the same. So you can go ahead and write down equilateral. Now, you might remember that an equilateral triangle is also equiangular. That's another one that we learned in that last lesson of the chapter. If it's equiangular, that means all of these x degrees are the same. So you could add up the x's, x plus x equals 180, so that's 3x. Or it's not a bad thing to just have memorized that an equilateral equiangular triangle has all its angles of 60 degrees, which is what you would get if you did this work. So you don't have to show this work over here. But you do have to tell us that x equals 60. So all these angles are 60. That means this is acute. And also, the definition of isosceles is a triangle with at least two sides the same. And this has two sides. This actually has all three. So this is actually isosceles as well. And you might remember this kind of triangle, an equilateral, equiangular triangle, is always going to be all four of these things, and its angles will also always be 60 degrees. That's not a bad thing to just know about equilateral, equiangular triangles. All right, number 3. Okay, so I don't know what all three of these angles are inside the triangle, but they do give me this angle right here. This angle, 3x minus 22, is called an external angle. And one of the first things we learned in Chapter 4 is that an external angle is equal to the sum of the two interior angles in the triangle that aren't right next to it. So not this angle here, but it would be equal to these two added up. So we would just need to set this up as an equation. 3x minus 22 equals 80 plus x. Now that theorem or postulate is in your packet, but that's a good thing that you should just know. So we'll solve this. So 2x equals 102. So if you divide that, x equals 51. Now, that is our answer, but we also need to tell what kind of triangle this is. So we need to know the rest of the angles inside. So this angle will also be 51. And so to get this angle, I would add 80 and 51 and subtract it from 180. So 80 plus 51 is 131. 180 minus 131. Alright, so 180 minus 131 is 49 degrees. So this angle is 49. Okay, so if we look at all three angles, 80, 51, and 49, none of them are the same, and they're all less than 90. The fact that they're all less than 90 makes this another acute triangle. The fact that none of them are the same means that none of the sides are the same. So this is also a scalene triangle. You're going to notice a lot of these are scalene, just because it's not always true that triangles have congruent sides. Alright, number 4. This is another external angle. So let's just go ahead and set this up. We'll set up 5x minus 2 equal to 2x plus 76. Then we'll just solve that. I'll subtract 2x from both sides. I'll add 2 to both sides. And then divide both sides by 3. 78 divided by 3 does come out evenly to 26. So there's my x answer. If I put 26 back in for angle B, 2 times 26 is 52 degrees. And then I still need to figure out this angle right here. So we know there's 180 degrees total in the triangle. So just like the last one that we did, we're going to add together 76 and 52. But then we're going to subtract that from 180. So 76 plus 52 is 128. 180 minus 128 is 52. So this angle is 52. So all three angles are less than 90. That makes this an acute triangle. But hey, look at this. 2 of our angles are the same. And so one of the rules we learned in our last lesson of this chapter, 4.7, was that if 2 angles are the same, that means the sides across from them will also be the same. So this angle, or this side and this side, are going to be congruent to each other. That makes this an isosceles triangle. If at least 2 sides are congruent to each other, the triangle is isosceles. Alright, on to number 5. This is a right triangle, and so all 3 angles will add up to 180, just like any triangle. But we learned a shortcut for right triangles. Since angle B is 90, that means the other 2 angles have to add up to 90. That way the total is 180. So instead of setting all 3 equal to 180, just add together the 2 non-right angles and set it equal to 90. They're going to have to equal 90. So 4x and 3x makes 7x. Minus 5 and 11 makes 6. And we just solve that. Subtract 6, we get 84. Divide by 7. And that is 12. So 12 is our answer for x. And then we plug that in. So if I do 3 times 12 plus 11, 3 times 12 is 36. Plus 11 makes 47. So this angle is 47. And you could plug 12 in up here for x, or since I know 47 and this angle have to equal 90, if you do 90 minus 47, you get 43. Alright, so this is a right triangle. We already mentioned that. It can't also be acute. I know sometimes people are like, oh, all the angles are under 90, so it's acute. But actually, no, this angle B is not under 90, it is 90. So a triangle cannot be both right and acute. It has to be one or the other. But since none of the angles are the same, that means none of the sides will be the same. So this is another scalene triangle. Okay. Number 6, another right triangle. So if you want, you can go ahead and write that down immediately so you don't forget this is a right triangle. Let's find x. So I'm going to do 8x plus x equals 90. So it's going to be 9x equals 90, because that's really like 1x. Divide by 9. and x equals 10. So there's my x answer. So that means this angle is 10 and this angle is 80. I already know there's a right triangle. None of these angles match though. I got 90, 80, 10. So this is another scalene triangle. If none of the angles are the same, none of the sides will be the same. Alright, number 7, another external angle problem. So let's set this up. 3x is our external angle. We're going to set that equal to 2x plus 30. Then we'll solve this. Subtract 2x, subtract 2x. Alright, x equals 30. So I have my answer for x. Let's put that back in. This means 2 times 30 will be 60. And so then 60 and 30 and what other angle add up to 180? Well, you could do what we've been doing and add 30 plus 60 and then subtract that total from 180. 30 and 60 makes 90, so that means the third angle will have to be 90. That means this is a right triangle. So I'll go ahead and put that down. This is a right triangle. And what about if are any of the angles the same? We got 90, 60, and 30. Nope, none of them are the same, so this is another scalene. Alright, number 8. Another external angle problem. Let's go ahead and set this up. 4x plus 8 equals 2x plus 3 plus 51. I'm just going to add those together right away to get 54. Then let's start doing stuff to both sides. I'm going to subtract 2x. So 2x plus 8 equals 54. Then subtract 8. 2x equals 46. Divide by 2. And x equals 23. So let's put 23 in for x up here. 2 times 23 plus 3. So that's going to be 46 plus 3. So this upper right angle is 49 degrees. And then we still got to come up with this angle right here. So you can do what we've been doing. You can add together the two angles that you know, which are 49 and 51. And then we can subtract those from 180. So 49 plus 51 is 100. 180 minus 100 is 80 degrees. So this angle is 80. So we have angles of 80, 51, and 49. They're all less than 90. That makes this an acute triangle. And they're all different. That makes this a scalene triangle also. Okay, on to number 9. Here we are given a little bit of information to begin with. The fact that we know these two sides are the same because they have the congruent markings. We learned in our last unit of Chapter 4 that that means the angles across from them will be the same. So this angle here and this angle here will be congruent. So let's set those equal to each other. They're going to have equal measures if they are congruent. Notice I have the exact same thing. If I start solving this, I'm just going to end up with 2 equals 2, and if I subtract those, I get 0 equals 0. So that doesn't really tell me anything. So even though those angles are the same, I'm still going to have to add up all 3 angles to 180. Because I just didn't get anything from setting those two equal to each other. They were already exactly the same expressions. If you realized that in advance, of course, you wouldn't have had to have even tried it. Alright, I got some like terms here. 2x, 2x, and 3x. Add all those together and you get 7x. And then I have 2, 2, and 1. And those are all positive. Add those together, you get 5. So subtract 5. 7x equals 175. Divide by 7. And x equals 25. So there is my x answer. And now you can put 25 back in. So if I start up here, 2 times 25 plus 2. 2 times 25 is 50. and 50 plus 2 will then be 52. And I know this angle over here is also going to be 52 because they're congruent. And so if I add the 52s together and subtract that from 180, I can get my third angle. So 52 plus 52 is 104. 180 minus 104 is 76. So this angle is 76. All right, so I got angles of 52, 52, 76. I actually already knew that this was an isosceles triangle because it was marked that those two sides were the same. That's how I knew that these two angles were the same. But now I can also see this is an acute triangle. They're all less than 90, so it is acute. All right, last one of these for a while. Number 10, another external angle problem. So let's go ahead and set this up. 6x minus 7, that's my external angle, equals 2x plus 103 minus x. I might take care of this 2x and minus x right away. Those together are just going to make x. Then I would subtract x from both sides. Then I would add 7 to both sides. So I get 5x equals 110. Divide by 5, and x equals 22. So x equals 22. All right. So if x is 22, 2 times 22 for this upper angle is going to be 44. Then I have to do 103 minus x. So you can just type that into your calculator. 103 minus 22, and you get 81. And then to get this third angle, you can do what we've been doing. You can add those two, 44 plus 81, but then we want to subtract that from 180. So 44 plus 81 is 125. 180 minus 125 is 55 degrees. So this angle is 55. All right, all three angles are less than 90, so this is an acute triangle. Also, all three angles are different, so that also makes this a scalene triangle. Okay, in numbers 11 through 20, we have a diagram of two triangles, and we are being told that those triangles are congruent. Remember that the order that those letters are in is important. That tells us, for instance, that A is congruent to G. Let me just mark that off here. Angle A is congruent to angle G. All right. Since L comes second and so does I, that means L and I are congruent angles. And since X comes last and W comes last, that means X and W are congruent angles. Okay. You can also see what sides are congruent if you look at the diagram there. You know, this LX side is between the two congruent markings and the three congruent markings. So that's going to correspond with IW, because that's also between the 2 and the 3 congruent markings. Let me just make that look a little nicer there. What else? LA, that's between the 1 congruent marking and the 2 congruent markings. So that's going to correspond to IG, because that's also between the 2 and the 1. So those two sides are congruent. And then the last two, XA and WG, are also going to be congruent. So I find it helpful to just familiarize myself with these two triangles, because if they're congruent, which they are, that means everything about them is the same, and you just want to know exactly how those match up. All right, so pay attention to the signs. There's a difference between equals and congruent. If you can give a number for an answer, do so. So LX. LX right here is congruent to what other side? Well, we already said that's congruent to WI or IW. You can say it either way. I don't really want to write it twice, so Just take your pick, either IW or WI. All right, number 12, angle I, that's up here. We already know that is congruent to angle L, and notice that's the symbol that's being used, congruent. So it's not asking for the degrees, it's asking for what angle it's congruent to. Number 13, angle A is congruent to what other angle? Angle A is congruent to angle G. You might be tempted to put down 55 degrees there, but it doesn't say the measure of angle A equals. It says angle A is congruent to, so you need to find the angle it's congruent to. 14, WG. WG, that's where I put 3 congruent markings, so that's going to be congruent to XA or AX. You can say it either way. Now, look at the next several of these. These do say the measure of, and so here we want a number. The direction says if you can give a number, do so. So the measure of angle A, that's the same as the measure of angle G, so 55 degrees. Number 16, the measure of angle W, let's see here, the measure of angle W, that's the same as the measure of angle X, which is 92 degrees. Number 17, the measure of angle I. We know I is congruent to L. I don't know exactly what that is right away, so I'm going to have to do some work here with this. Well, I know that X and W are the same and that this is 92 degrees. So if I add 92 and 55, I get 147, and then I'm going to subtract that from 180 to figure out the remaining angle. So 180 minus 147 is 33 degrees. So that means angle I is 33 degrees, along with angle L is also 33 degrees. So I'll go ahead and fill both of these in. I is 33 degrees, the measure of angle L is also 33 degrees. Alright, number 19 says IW. IW is right here, and we want to know what's that equal to. Well, it's equal to the same length as LX, but we know LX is 4. So let's be more specific and just put down 4, or 4 centimeters. And then lastly with this setup, number 20 is saying triangle LAX. What we're doing there is we're just reversing the order that it's in. They at first said ALX, so now they're saying LAX. So we need to make sure to line that up. LAX. We need to write the other triangle in an order that would match up with that. So which angle is congruent to L? That would be I. Which angle is congruent to A? That would be G. Which angle is congruent to X? That would be W. So it would have to be triangle IGW. It must be in that order. Alright, with the next set of problems, the directions say, state the congruence that is needed to prove triangle DEF congruent to triangle QRT. In other words, how are you going to prove these triangles congruent to each other? Use the given postulate or theorem. I think it's very, very helpful to mark the diagram for what's given. So, number 21, given. Angle D is congruent to angle Q. Alright. Angle F is congruent to angle T. We want to use AAS to prove that these two triangles are congruent. So, I already have AA, I just need an S. Now it's not ASA, so the side should not be between those two. So one way of doing this is to say these two sides are congruent. So that would be DE congruent to QR. So that works. There actually is another way to use AAS also. What if we had this side and this side? That is also still AAS. So there's actually two possible answers. You only have to say one or the other, but since I'm explaining this, I want to tell you both. So the other possibility would be EF and RT. So two possible answers for this one. Alright, number 22. It's given that angle E is congruent to angle R. It's also given that side EF is congruent to side RT. Now here we do want to use ASA, so angle side. If we want to use ASA, it would have to be angle F is congruent to angle T. Alright, number 23. It is given that DE is congruent to QR, and it's also given that angle D is congruent to angle Q. we want to use SAS. So we already have a side and an angle. We need another side, but it has to leave the angle in the middle between the two. So that means it would have to be DF and QT. That's the only way that you're going to have SAS in order, where the angle is between the two sides. So let's write that out. Side DF is congruent to side QT. Now I think it's very helpful to mark the diagram like you've seen me do here, but make sure you actually write it out. The directions say state the congruence, so you need to state it. All right. Decide whether the triangles can be proven congruent by the given postulate or theorem. So in this example, we want to know, are the triangles congruent by ASA? So what do we have here? We have an angle. We have another angle. Using vertical angles, I can say that these two middle angles are congruent. But I don't know anything about all the sides. AAA is not a rule, so no, we can't use ASA to prove these triangles congruent. Let's look at number 25. We want to use AAS. So again, let's use vertical angles to say that those two are congruent. Do we have AAS? Well, AAS. Yes, we do. So those triangles are congruent by AAS. All right, number 26. We want to use SAS. Right now we have an angle and we have a side. I know that this middle side is shared between those two, but that's all I know. So what is that? SSA? Yeah, that doesn't work. So number 26, the answer is no. 27, we want to use SSS. Well, I know all these pairs they give us are congruent. I also know by the reflexive property this middle side will be congruent. So our answer is yes. That would work by SSS. All right. The last thing that we learned in Unit 4 is that if two sides are congruent, the two angles across from them are also going to be congruent. So we're going to use that rule to solve to find x, and then we're going to try to classify the angle as much as we can. It's possible we won't be able to fully classify it, and I'll explain why when we get to one. All right, so we can see that this triangle is equilateral. All three sides are the same. If you want, you can go ahead and write that down right from the beginning so you don't forget. We also learned that all equilateral triangles are also equiangular. If all three sides are the same, then all three angles will be the same. So this angle, this angle, this angle, they're all going to be the same. And so if they're all the same and there's 180 degrees total, that means they all have to be 60. That's a good thing to just know, that in an equilateral equiangular triangle, all the angles are 60. So we can set this up, 5x equals 60. Divide by 5 to solve, that x equals 12. Now, if all three angles are 60, that also means this triangle is acute. And then lastly, you might remember that a triangle like this, an equilateral equiangular triangle, is also going to be isosceles. I know we think about isosceles as a triangle with two congruent sides, but technically the definition is at least two congruent sides. So anytime you have an equilateral equiangular triangle, it's going to be all four of these names. All right, let's take a look at number 29. So, okay, in this example, I see that the two angles are congruent, A and C, and we learned that if two angles in a triangle are congruent, the sides across from them will be congruent. So across from C is this side, across from A is this side. So those two sides will be congruent, so let's set them equal. 28 equals 9x minus 8. I'm going to add 8 to both sides. So we'll get 36, and then divide by 9, so x equals 4. Alright, now I do know that this is an isosceles triangle because two of the sides are congruent. With what we've learned so far, I don't really know what the angles are. If I had to guess, I'd say it's acute, but we don't know for sure. We're going to have to learn some trigonometry in order to figure that out. Number 30. Okay, So this is kind of the opposite. We have two sides that are the same. That means these two angles will be the same. Now you might be tempted, because this is also 11x minus 18, you might be tempted to set these two equal to each other, and indeed they are equal measures, but you're not going to get anywhere. Let me just show you what happens, and then I'll erase it. If you set 11x minus 18 equal to 11x minus 18, if you try and solve that, let's say I get the x's on one side or the other, both x's go away. And you're left with a true statement, but it's not a statement that tells you what x is. So it's like it doesn't do you any good. So let me back up here. So what we're going to do is we're going to remember the rule that in any triangle, all three angles add up to 180 degrees. Don't forget that rule. It's kind of the most basic thing we learned about triangles and their angles. So I'm going to set all three of these equal to 180. If I add like terms, 11x and 11x makes 22x. And then minus 18, and 40. If you add all three of those up, just type into your calculator, negative 18 plus negative 18 plus 40, you get 4. Okay, let's subtract 4. So 22x equals 176. And then let's divide by 22. So 176 divided by 22, and we get 8. So our answer for x is 8. We did know that this was an isosceles triangle right from the beginning because two sides are the same. And we do know the angles of this, or at least we can figure it out. So we just figured out that x is 8. So if we put an 8 in for x, I'm going to enter into my calculator 11 times 8 minus 18, and I get 70. So this angle is actually 70 degrees, and we know this one's also going to be 70 because we know they're congruent. So all three angles are less than 90. That means this triangle is also acute. We know that for sure. All right, on to number 31. These two angles are both 60. That means the sides across from them are congruent. So if you wanted to put down right away that you know this is isosceles, you could do that. And that means the third angle, 60, 60, oh, the third angle is also going to be 60, right? Because it has to add up to 180. This is actually one of our special triangles. This is going to be isosceles, equiangular, equilateral. So actually this side will also be the same. And it's going to be acute. If all three angles are less than 90, it's acute. We still have to find x, so I'm just going to set 2x minus 3 equal to 7. We'll add 3, and we'll figure out that x equals 5. Okay, so yeah, we didn't know it from the beginning, but we figured out that that's an equilateral, equiangular, isosceles, acute triangle, and that x equals 5. All right, on to number 32. You know, we might notice something about this one right away, too. All three angles are the same. That means all three sides will be the same. This, again, is an equilateral, equiangular, and we know then it's also going to be acute and isosceles. If it's one of these special triangles, it's going to have all 4 names. Now we still have to solve this, but if we know that these two sides are equal, we can just set them equal to each other and solve. So let's see here, I'll subtract 5x from both sides, and then I'll add 11. And it looks like this one's not going to work out completely evenly. That's okay. If I divide both sides by 4, 27 divided by 4, it comes out to 6.75. I'm not rounding, that is just what it comes out to. So there we go, we got our answers. Number 33, okay, these two sides are the same, so therefore these two angles will be the same. So if you want to write out that this is isosceles right from the beginning, we can do that. Let's go ahead and set these equal to each other. 7x plus 5 equals x plus 47. Subtract x from each side, and we get 6x. Subtract 5, and that equals 42. So divide by 6, x equals 7. Now, I don't currently know any of the angles, but we can figure them out. If we put a 7 in for x, we can do that. So I'm going to do 7 times 7 plus 5. 7 times 7 is 49. 49 plus 5 is 54 degrees. So this is 54 degrees. This is also 54 degrees. To figure out this third angle, we can add 54 and 54, that's 108, and then subtract that from 180, since I know there's 180 degrees total. So 72 degrees. So 54, 54, 72, this is also an acute triangle. And there we go. Alright, last three problems here are proofs. Chapter 4 was big on proofs because one of the main parts of Chapter 4 was proving that two triangles are congruent to each other. And the best way to do that is to show in a proof. So in number 34, you can see that we have two triangles that are connected through AC. You can also see that we have some parallel lines going on. Now, it doesn't tell us that anything is given, but things are given. Anything that you see on the diagram that's marked is given. So I'm going to start off by saying that it is given that DA is parallel to CB. You can see that they're marked. And while I'm at it, let's say that DC is parallel to AB. So those things are given. The reason why I know them and I can state that is because it was already on the diagram. It is given. Now, a lot of you would right away tell us that AC is congruent to itself by the reflexive property. And yeah, I think we will need to know that to do this proof. So let's go ahead and write that down. You know, after you write the given, the other steps, sometimes their order can vary. Sometimes there is a specific order it should be in, but on one like this, if you wanted to go ahead and state that AC is congruent to itself because of the reflexive property, you could do that right away, or you could do it later in the proof. Now, we got to think about why are they telling us these lines are parallel? My guess is it has something to do with the fact that when we have two parallel lines cut by a transversal, we know lots of things are going to be true. We spent a whole chapter, chapter 3, on studying those relationships. So for instance, I would know that this angle and this angle are congruent because they're alternate interior angles. So that would be like here and here. So when I look at this, I would say that angle DAC, you have to use 3 letters to name that angle. I know you might just think of it as angle A, but if you say angle A, do you mean this one? Do you mean this one? Or do you mean the whole thing? So if it's not clear, you got to use 3 letters. So angle DAC is congruent to angle, how about BCA or ACB? You could say it in either order. And since those are alternate interior angles, the reason why they're congruent is the alternate interior angle theorem, or you can say alternate interior angles. All right. If you want, we could say the same thing about these angles right here. Those are also alternate interior angles. So I'm just going to put a quote sign down there. And so that would be angle BAC. And in the left-hand triangle, that would be ACD. So we want to prove these triangles are congruent. And now we have what it takes to do that. We have an angle, a side, and an angle in each one. So we have ASA. So by ASA, these triangles are congruent. Now for this proof, I chose to use alternate interior angles as kind of the integral part of it. But there were other ways to do this. You know, you might be able to use corresponding or alternate exterior, consecutive interior, some other way. And that's why with proofs, answers will vary. But here's my suggested way of doing this proof. All right, number 35. This is a proof that we did in class together, but I'll do it again right here for us. Maybe you weren't in class or you just wanted to take a second look at it. So, statements, reasons. Again, even though it doesn't look like we have anything given, because it doesn't say given, we do have things that are given. For instance, the fact that PR and RS are congruent. That is given. So I'm going to go ahead and write that in here. PR is congruent to RS. You could also say RP or SR. So that's given. It's also given that angle P is congruent to angle, it might be tempting to say angle R here, but if you say angle R, we don't really know if you mean this angle, or some combination of them, so you're going to have to use 3 letters for this. So we're going to say SRT. Alright, those things are given. I didn't even say what are we trying to prove here, and what we are trying to prove, if you look up above, is that side ST is congruent to side RQ. Now, one of the ways that we do that is we first prove the 2 triangles congruent. So let's put that on hold and just concentrate on proving the 2 triangles congruent. Again, we have some parallel lines. That might be a good idea to state in the given as well. The fact that RQ is parallel to ST. That is given. Those signs are there. So what I think of when I see that, I think of 2 parallel lines cut by a transversal like this. I know that these 2 angles would be congruent because they're corresponding. So that would be like this angle and this angle. So, because they're corresponding angles and the 2 lines are congruent, I'm going to say that angle S is congruent to angle PRQ. And now, look at what we have. We have ASA. So by ASA, let's say triangle SRT is congruent to triangle RPQ. I know often in this chapter that's where we ended. We said the triangles are congruent, we're done. But remember what we're trying to prove here. We're trying to prove ST is congruent to RQ. ST congruent to RQ. And so that's what we're going to say next. And that'll be our last step of the proof. But let's talk about why that's true. So here's the deal. We have proved these 2 triangles congruent. We did it by ASA. And so what we're saying now is that ST has to be congruent to RQ, because these triangles are congruent, and all the parts of them that correspond are also going to be congruent. That's kind of a lot to write out, though, as far as our reasons go, to say these 2 triangles are congruent and therefore their corresponding parts have to be congruent. Rather than writing out those 2 sentences, we have a shortcut, and that's CPCTC. That stands for corresponding parts of congruent triangles are congruent. It's just a shorter way of saying because these 2 triangles are congruent, all their corresponding parts are also going to be congruent. If I wanted to, and I don't really want to in this case, but if I did, I could also say that angle Q is congruent to angle T because of CPCTC, or side PQ is congruent to RT because of CPCTC, or what we did, which is that ST is congruent to RQ because of CPCTC. Okay, the last problem. In number 36, our last proof here, we have 2 intersecting triangles, as you can see, and ultimately what we're trying to prove is that angle CJF, that's this angle right here, is congruent to angle GHD, that's this angle right here. And notice what we are given. I've already written down the given information here. The fact that angle C is congruent to angle G, angle D is congruent to angle F, and side CD is congruent to side GF. So you do need to write that down. That is given, even though nowhere does it say given. Those things are given to us on the diagram. So what I notice when I look at this is, since we are given an angle, side, and angle congruent to each, we have ASA. So by the reason of ASA, we can say that these triangles are congruent to each other. So I'm going to say triangle DCH is congruent to what triangles here? DCH. So I have to make them line up. D is congruent to F, C is congruent to G, and I'm going to assume J and H go together. So this is going to be F, G, J. Now, we know that when two triangles are congruent, all of their parts are congruent. So, unfortunately, I can't say that these two angles, the ones that we're trying to prove, I can't jump right away and say those are congruent because those aren't really parts of the triangles. But I can almost get there. I can say that angle FJH and angle DHC are congruent because they're parts of corresponding triangles. So CPCTC, corresponding parts of congruent triangles are congruent. Alright, so I have that written out. Now, what you may notice is that the two angles that I want to prove congruent to each other, the ones that I'm supposed to prove congruent, because that's the point of this proof, are right across from two angles that are congruent to each other. And our angles are supplementary. You can see they are a linear pair. And so I want it to make sense to you that if these two angles are supplementary to congruent angles, then they too must be congruent. That's actually a theorem that we learned a month or two ago. It's called the congruent supplements theorem. And it's built exactly for a situation like this, where if you have two angles that are supplementary to the same angle, or two congruent angles, then those angles must be congruent. So we're going to be able to say that angle CJF is congruent to angle GHD by the congruent supplements theorem. This is how I would do this proof. Alright, good luck with your studying.